Alright guys, this is the second half of section 1 from chapter 2. We're going to talk about what happens when we take individual elements and we combine them and put them together. And I have a friend, some of you guys have asked me about my puppy, and so he's sitting on my lap, he's hanging out with us today. His name is Wicket. Hi Wicket, can you say hello? There he is. Okay, so let's talk about compounds. A compound is a substance that is formed by the chemical combination of two or more elements that are in definite proportions. And so when we mean definite proportions, we could also say specific proportions. When we talk about water, it's H2O. It's not H3O or H4O. Water comes in the form of H2O. The physical and the chemical properties of compounds are going to be different from when the elements were separate. So when you look at water, H2O, hydrogen gas, H2, and oxygen gas, O2, are very different from when they are formed together. And if you can see, O2, oxygen, the gas that we breathe, is actually in an O2 form. Right? In water, there's only one oxygen, but in the gas that we breathe, oxygen in the atmosphere, it is in two form because O by itself is actually quite unstable because it's needing some electrons to join in. We'll talk about that later. Secondly, NaCl. Na is sodium, Cl is chloride, and NaCl is table salt. So this powder, a white substance, right? We like this. We like to put it on French fries, on popcorn. It tastes great. But this by itself, sodium, is actually a soft metal and it can be quite explosive. It's a silvery metal by itself, and Cl by itself is a greenish gas that was actually used in World War I as a poison. So when the two combine, right here, not poisonous, it's something that we like to put on our food. All right, atoms are held together by various types of bonds, and we'll talk about those bonds in a moment. Bond formation is going to involve electrons that surround each atom of a nucleus. So remember that electrons have a negative charge and they are not fixed to a position, but they are floating around in the electron cloud. So that allows for the bonding to occur quite easily between different elements. And we name those electrons that are able to form bonds, we call them a valence electron. It's a fancy name that tells us that these are electrons that are available for bonding. And there are two main types of bonds that we'll discuss, and those are ionic and covalent bonds. So let's first discuss ionic. Ionic bonding is when one or more electron is transferred from one atom to another. And notice the things that I'm underlining here. I'm underlining the fact that an electron is transferred. It's actually given away from one element or one atom to another. So an atom that loses electrons, the one that's actually giving up an electron, is becoming positively charged, and an atom that's gaining, the one that's receiving the electron, is negatively charged. And I don't know of a great way to remember this because I struggled with how to remember. The one thing it's kind of silly, but I like to create really weird things that help me remember information that I need to know, is that it's a happy thing to give away something, right? It can make us happy to give away a gift. And so if an atom is losing an electron, it's because he's actually giving it away as a gift, and so he becomes positive. I know that's kind of weird, but that's how I just remind myself and remember it. And the one that is actually receiving the electron, well, he is happy that he's getting the electron, but he's sad because he wasn't able to share. So if that helps you to remember the difference between losing and gaining electrons, then steal it, use that as a reminder. Or if you could think of a different way to remember this, you should share that in class. And we know we know them to be ions. So atoms that can give away these electrons, we call them ions. And they will have positive and negative charges. Okay, so for example, let's take a look at NaCl, also known as table salt. So we can see that we have sodium and chlorine together. Sodium has an overall charge of 11 protons and it has 11 electrons. So together NaCl will have a 0 charge, and the protons that are on chlorine are 17, electrons are 17. Because sodium is actually giving away an electron, it's transferring it over, it's happening right here, okay? Because it's giving it away to chlorine, the charge is going to change. It's giving away an electron, so it loses an electron, and when you do the math between protons and electrons, the overall charge is a +1. And because the chlorine gained an electron, the overall charge is a -1. So that's where those charges come from when we talk about a positive or a negative charge. Now remember that ionic bonds are taken, they are not shared. Here is a wonderful meme for you to stare at. I know you were laughing inside right now. I know this is the funniest picture you've ever seen. So the name is bond, ionic bond. They are taken, not shared. So another way to remember it is that opposites attract. Weird personalities just attract each other, and you can even think of a battery. A battery has a positive and negative charge, and when you have a battery, you put the opposite ends together. So remember that opposites attract. If an atom is positive and one is negative, it's possible that they could form an ionic bond. Now let's take a look at covalent bonding, our second type of bond. In covalent bonding, our electrons are actually sharing between atoms. And the structure that comes from atoms that are joined together by a covalent bond, because they're actually sharing electrons, is called a molecule. And a molecule is the smallest unit of most compounds. So let's talk about the hydrogen atom. A hydrogen atom by itself is pretty unstable. It's not happy that it's missing an electron. And so what hydrogen atoms will do is they will actually come together and form a covalent bond. And they are going to share the bond between each hydrogen atom. And this is a hydrogen molecule. So these electrons will float around, keeping them bonded together, but they're not transferred, they're not given away like ionic bonds. They're actually shared between the two of them. And another lovely meme for you. You have a joke about covalent bonds. Do share. So hopefully that can help you remember that covalent bonds do share. I love me some cheesy jokes because hopefully you'll remember some of these little tricks to remember some of this information. So again, simply put, I want you to really understand that the bond is shared, okay? You can say that out loud because remember, if you're talking about biology, you're the one that's learning biology. And another trick that could help you is think about the word covalent. If something is okay, we are talking about a co-pilot, a co-worker. Covalent bonding, we are sharing the workload, we are sharing the job. Okay, one more very important type of bonding and attraction that we see is called a van der Waals force. So because of the structure of an atom, not all atoms are going to have the same ability to attract electrons as other atoms do. Some have weaker attractions and some have stronger attractions. So when the same molecules are close together, there's a slight attraction that can basically develop between the oppositely charged portions that are nearest to the molecules. And so what that means is molecules that are the same, so for example, there's going to be lots of tiny molecules here all over the foot of this gecko, will have an attraction for each other. And so the molecules will all come together and will form this structure that we get onto a gecko's foot. And now the gecko has the ability to stick to the wall. And it's due to the molecules that on a very, very microscopic level that are having an attraction for each other. But we have to remember that we are talking about the same sort of molecule. So it has to be the same. Same molecules having that attraction toward each other, and that is called the van der Waals force. They're not as strong, and there are different types of van der Waals forces that we will discuss, especially when we look at water. How do water molecules all come together? But those are really important properties for molecules as a whole.